Okay, AP Chem, we're going to go over the answer key for the titration quiz. First of all, there's a few things that were confusing, so I get why some of the things were missed. So it says, the first one says, which letter is the half equivalence point? Well, the half equivalence point would be halfway between the equivalence point here and the start here. So halfway between there is here. And the arrow that points there is actually D, but I also gave you E in case that was a little confusing as to where the arrows were pointing to. Sometimes it didn't translate well. So this should have been D, but you got credit if you put E also. Obviously, the equivalence point is B. Now, in the instructions, it said don't try to read the graph and that the graph was only for numbers 1 and 2. So hopefully you didn't make the mistake of not reading the instructions. Number 3 says how many moles of acid are present initially. Before the quiz even started, I did mention that you're not supposed to read the graph to try to answer the question. You're supposed to use the numbers. And in the instructions, it did tell you to calculate with your numbers, not reading the graph. So number 3 states how many moles of acid are present initially. So you go up here and you're going to say I had 0.2 moles per liter. I'll use HA to indicate my weak acid. Save us some time. In 1 liter. But I didn't have 1 liter. I had 50 milliliters. So 0.050 liters. So the answer becomes 0.010 moles of weak acid. That's the answer to number 3. 4 says, what is the initial pH of the weak acid? So the initial pH, if you remember, you can do your ice chart if you need to, but the general formula is the Ka for weak acid is equal to x squared over the initial concentration. And then you do negative log of x to get the pH. Because when you do the ice chart, remember that this is the initial concentration. I also saw people getting confused and using the number of moles instead of the initial concentration. So the initial concentration is 0.2. Remember, ice charts always have molar. So if you put 0.01 in there, that's a common mistake I saw made. These guys have 0. This is minus x. This is plus x. Remember that this x is so small that we're not going to worry about it. And that's the x squared over 0.2. And x is going to give us the concentration of H+. That's why the negative log of x gives us the pH. So Ka is given to us as 1.33 times 10 to the minus 5. And then we're going to solve for x. Initial concentration is 0.2. So x in this case is 1.63 times 10 to the minus 3. That's the concentration of H+. So that I can do the negative log of x and I get a pH of 2.79. That's the answer to number 4. Number 5 says, which ion is the spectator ion? Well, let's remember that definitely H plus takes part in this. OH minus takes part in this. The weak acid takes part in it, and so does its conjugate base. The one that is always the spectator ion, and anytime you see this, you want to have a red flag go up, that Na plus is our spectator ion. Number 6 says, what is the pH at the half equivalent point? At the half equivalent point, the pH is equal to the pKa. So it's going to be negative log of Ka, which is given to us as 1.33 times 10 to the minus 5. So I take the negative log of the Ka, and I get an answer of 4.88. That's the answer to number 6. Number 7 says, how many of milliliters of NaOH would be required to neutralize the acid? This is where I saw some people trying to read off the graph. Well, we go back up to the top. If we had 0.01 moles of HA, that would take 0.01 moles of base to neutralize it. That's because it's a single hydrogen, or H+, so it is a monoprotic acid. So therefore, there's 1 H+ for every 1 mole. So 0.01 moles of HA has 0.01 moles of H+, and that would require 0.01 moles of NaOH, because 0.01 moles of NaOH has 0.01 moles of OH minus. I go up and I look and I see that there's 0.25 moles of OH in 1 liter of solution. So the answer for this is going to be 0.040 liters, or 40.0 milliliters. That's the answer to number 7. What is the total volume at the equivalence point is what number 8 asks you. Well, I started with 50 milliliters of acid, and I added 40 milliliters of base. So remember, volumes are additive. So the volume at the equivalence point is 90 milliliters. Now, number 9 was the one I saw was missed most often. How many moles of the propanoate ion, or the conjugate base of the weak acid, so it's HA, are present at the equivalence point? Well, let's go back up to the beginning. We had 0.01 moles of weak acid. 0.010 moles of HA has 0.010 moles of A minus. That is not going anywhere. So the A minus did not go anywhere. It did not chemically combine with anything else. It is still floating around in solution. So it's there at the beginning and it is there now. Then it says, what is the concentration of the ion at the equivalence point? So number 10, if we're looking for concentration, remember concentration is the number of moles over the number of liters. So this is going to be number 9 divided by number 8. That's the concentration of the conjugate base at the equivalence point. Now, the last thing, which is let's go over here. Number 11 says, what is the KB? Remember, KB is KW over KA. To give me 7.52 times 10 to the minus 10. That is the KB for the conjugate base of the weak acid. Number 12 is probably the toughest one. It's asking you for the pH at the equivalence point. So here we have a situation where KB is equal to X squared over the concentration. So that's going to be number 11 is equal to X squared over number 10. This time we have to remember that X squared in this case, because it's KB, X is going to be the concentration of OH minus. So the negative log of X in this case will give me the POH. So the answer for X is 9.14 times 10 to the minus 6. The negative log of that is 5.04. The pH is going to be 14 minus 5.04 then. For 8.96, that's the answer to number 12. Let's do that one more time for quiz B. Again, the half equivalence point here would be halfway. This is the only time we're reading off the graph. This would be the equivalence point. So the answer would have been D, but I also gave you credit for E and then B. Moles of acid present initially is molar times volume. So the answer for number 1 is 0.0125 moles. That's how many moles of weak acid are present initially. That's the answer to number 3, sorry. What's the initial pH of the acid? Remember, that's going to be Ka equals x squared over initial concentration, not the number of moles, because it comes from our ice chart, and ice chart always has concentrations. So 1.74 times 10 to the minus 5th is our Ka, and we're going to solve for x. So x is 2.09 times 10 to the minus 3rd. So the pH is negative log of x, because that's the concentration of H+, or negative log 2.09 times 10 to the minus 3rd. And I get a pH of 2.68. That is the answer for number 4. 5. What is the spectator ion? This time again, it's sodium hydroxide, so it's sodium. What is the pH at the half equivalence point? pH is equal to pKa. Or negative log of 1.74 times 10 to the minus 5. Or 4.76. That's the answer to number 6. Number 7 states how many milliliters of NaOH would be required to neutralize the acid. This is also 1-to-1, so I have 0.0125 moles of acid that has 0.0125 moles of H+. It would take 0.0125 moles of OH minus. And this is a 1-to-1 net ionic equation. So this tells us that 0.200 moles of NaOH has 0.200 moles of OH minus in 1 liter of solution. So 0.0125 divided by 0.2 gives me 0.0625 liters of solution, or 62.5 milliliters. That's the answer to number 7. Let's go on to number 8. What's the total volume in the flask at equivalence point? Remember that volumes are additive. So you take your initial volume and add it to the volume of hydroxide that you added. The answer to number 8 is 112.5. 9 says, how many moles of the ethanoate ion, the conjugate base of the weak acid, are present at the equivalence point? Same thing. We started with 0.0125 moles of weak acid. Therefore, the conjugate is going to be the same. What is the concentration of the conjugate base at the equivalence point? Remember that concentration is the number of moles of A minus divided by the total volume. This one I saw some people forgot to change the milliliters back to liters. This time I get 0.111 molar. What is the KB? Number 11. KB is KW divided by KA. For 5.75 times 10 to the minus 10. Number 12, the pH at the equivalence point. That's the tough one. So let's do that again. Remember, KB is equal to x squared over the concentration. And then negative log of x gives me the concentration of OH minus. So KB is 5.75 times 10 to the minus 10 equals x squared over the concentration, which is 0.111. So I'm going to solve for x now. And I get 7.99 times 10 to the minus 6. So negative log of x gives me 5.10. And my pH is 8.90 because this is POH. So pH is 14 minus POH. That is my answer for number 12.